All right, now we're going to compare these different models that we just created. So we have our neural network, we have our random forest, our classification tree, our support vector machines, as well as the k-nearest neighbor. So we want to put all of these in one script so we can see which one performed best and generally compare their performance. So to make this a little bit easier, we're actually going to copy some of our code from up here. So we'll go ahead and copy all of this. And then at the very, very top, I'm going to add a few imports that we've used before, the IPy widgets. And then specifically, we're going to take the interact and interact manual. And the idea here will be to build a quick interface that allows us to compare the accuracy and performance of different modeling approaches. Now what we want to do is actually load in all of our models. What I did was I went through each one of these and I copied this line. So this is the scikit-learn neural network classifier. This is the random forest classifier. All I did was I copied all of those into one block. And I'm going to go ahead and put that down right here. So now we have all of our different models kind of in one spot. With that, let's go ahead and run this and just make sure that we're doing okay. I am going to go ahead and get rid of this print y because we no longer need it, and that will clean up our code. Just like we did a few labs ago, we're going to define a manual interaction where what we want to do is let the user select the model that they want to visualize. So we'll do @interact manual. All right, so this describes our interact manual. So this is just what we'll want to prompt the user with. If you were to click, run right now, you're going to get an error because we don't have any further code. So there's nothing else going on here. The next thing we want to do is actually run the define the model itself that we're going to be running with this. So every time that a user selects something, we need to have a defined function that actually does something with their selection. What we want to do is a couple of things. First, we want to display the results from the model. So, they select a user selects something, we want to show them this screen for the model that they've chosen. And then we also want to output the accuracy for that model. Just to pause for a moment here, everything that you see in this code is the exact same as we did above. There's nothing new in this defined function relative to what we've done before. We're first saying, based on what the user selected, pick the appropriate model. So we're saying, give us a k-neighbors classifier, a SVC, whatever the case might be. Go ahead and fit that model, and then pass it forward into the exact same code we've used for visualizations. Literally just copy and pasted from above. So if we run this, we now have down here the model selection. So if I pick, for example, decision tree, and then I click run interact, what will happen is this word selection will be replaced by decision tree. We'll go through these if statements, and it will say, okay, this is true. If selection equals decision tree, model will be defined as this model. And so we'll actually have the decision tree classifier fit. And then we go through our normal visualization. So if I click run interact here, you'll see this is the output from the decision tree classifier, which should look very, very familiar, right? We have that same break. I mean, it is the same model. What we want to do now is we want to add to this. We actually want to add some measurement of accuracy. So to do that, we're going to make two kind of pretty straightforward changes. First, we're going to import one of our accuracy metrics, and this will just be the absolute simplest accuracy metric. It's the % of the time our model gets it right in terms of its internal accuracy. And then what we're going to do as well is we're actually going to modify the plot title. So we're going to change the title to just be a little bit cleaner. And so just to walk you through this, the new plot title, and you'll just replace this in your code. I have the string of the selection. So this is whatever word the user selects in the model. And then plus the word accuracy with spaces around it. Plus, and this is where the actual accuracy calculation is done. So accuracy score, comparing y, our known y's, to our predictions of y's. So this is the binary classification. So if I run this, we'll go ahead and run this, and then we'll run the interact. Now we have, so for nearest neighbor, we have a 0.879. Let's run radial SVM. So we have 0.87 decision tree, 0.86 neural network, 0.85 in a random forest. 0.874. So random forest was 0.874. Nearest neighbor, we're seeing 0.879. So in this particular case, nearest neighbor is the most accurate of our models. Now, obviously, there are lots of different ways you could display the accuracy. You could create a table, you could print it all out at once, you could create a data frame, whatever you want. But in this case, this is just a quick kind of, nice user interface way to visualize what the most accurate model is and kind of why that model is the most accurate. In the next video, and the final video, we're going to now apply this nearest neighbor algorithm to a real-time data stream.